So let's look at how we might use the 68, 95, 99.7 rule. So I have scores on the ACT in a recent year were normally distributed with a mean of 20.8 and a standard deviation of 4.8. If 1,000 incoming students took the test, how many students would we expect to have scores between 11.2 and 30.4? And how many scores would we expect to be above 25.6? So anytime you have a problem in this unit with normal distribution, so it says the distribution of scores were normally distributed, the first thing you should do is draw a picture. So we're going to draw a normal curve, so it's a bell-shaped curve with a single peak, and we're going to put the mean right at the center. So we're told that the mean is 20.8, so there's my mean. The next thing I want to do is mark off the points that are 1, 2, and 3 standard deviations away from my mean. So to do that, I'm going to take my mean and add 1 standard deviation. So this is my mean, 20.8, plus 1 standard deviation, 4.8. That gave me 25.6. To get the next point, I'm going to add 4.8 again. That's the same as 20.8 plus 2 times 4.8. And then this value, 35.2, is the mean, 20.8 plus 3 times the standard deviation. Now to the left of the mean, we're going to mark 1, 2, and 3 standard deviations below the mean. So now we're going to subtract. So this is 20.8 minus 4.8 is 16. 20.8 minus 2 times 4.8. And then 20.8 minus 3 times 4.8. Now, when you're drawing your picture to make your picture look nice, these points happen at the inflection points in your curve. So the first place that my curve is sort of switching from going down to going up is where that first standard deviation away goes. And then the next inflection point is about here and then here. So that just helps you draw your picture nicely. All right, so we want to know how many students we would expect to have scores between 11.2 and 30.4. Well, 11.2 is over here, and 30.4 is over here on the right. Each of those is 2 standard deviations away from the mean. And lucky for us, the 68, 95, 99.7 rule has something to say about numbers that are 2 standard deviations away from the mean. So the rule says that if I go 2 standard deviations on either side of the mean, then 95, you can't really see that, let's switch to black, 95% of the data is within 2 standard deviations of the mean. All right, so we would expect 95% of the scores to be between 11.2 and 30.4. And we know that 1,000 students took the score, so I want 95% of 1,000, or 0.95 times 1,000, and that's 950 scores. Oops. All right, let's look at the second question. How many scores would we expect to be above 25.6? So I'm going to erase what I've shaded here, and let's look at 25.6. So 25.6 is 1 standard deviation to the right of the mean, and we want scores above. So I'm looking to find what's the percent of scores that would be in this yellow shaded region. Well, we want to use the rule, and the rule tells us that if I go 1 standard deviation to the left and 1 standard deviation to the right, this is 68% of my data. Right? All right, so this is 68% of the data, and we know that the normal distribution is symmetric. What that means is that on either side of the mean cuts it in half, and it's symmetric. So the total area is 100% under the curve. And so what's left is 100 minus 68, or 32% left. And that's got to cover both this left tail and this right tail. Now, by symmetry, since these are both one standard deviation away from the mean, these two tails must be equal. So if they are equal and they add to 32, then I can figure out what one of them is by just dividing 32 by 2. So this tail here is going to be 100 minus 68, that was my 32, divided by 2. And that gives me 16. So 16% of the scores will be above 25.6. And if we wanted to count, I'm going to take 16% of 1,000, or 160.